Experiment number 11. Identification of anions. Sulfate, sulfide, thiosulfate, sulphite, carbonate, nitrate, and nitrite ions will be identified in this experiment. Objectives: identification of sulfate, sulphide, thiosulfate, sulphide, carbonate, nitrate, and nitrite ions in an aqueous solution. Identification of carbon dioxide gas to gain skills in the use of delivery tubes. Equipment, chemicals required for this experiment. Procedure. You have provided a sulfate solution. Add few drops of barium chloride solution to it. A white color precipitate observes. Then add diluted hydrochloric acid for that precipitate. Precipitate will not dissolve. Observations and results. For the given sulfate ion solution, when we add barium chloride, barium sulfate is produced. It is a white color precipitate. Barium sulfate will not react with diluted hydrochloric acid, so precipitate stays. You have provided a sulfide solution. Add barium chloride to the given solution. A white color precipitate observes. Add few drops of diluted hydrochloric acid. Precipitate dissolves. Place a blue litmus paper on the top of the test tube. The color will change to red in color. A powder of sulfite ions has given to you. Dissolve it by using diluted hydrochloric acid. Then heat the mixture for several minutes. Then place a filter paper moistened with acidified potassium dichromate over the mouth of the boiling tube. The color will change to green. Observations and results. When we add barium chloride for the given sulfite ion solution, barium sulfite precipitate forms. It is white in color. After that, when we add diluted hydrochloric acid, barium sulfide will dissolve and produce sulfur dioxide. Sulfur dioxide is an acidic gas, so it can change the color of blue litmus to red. In the second part of the experiment, when we add hydrochloric acid to the given powder, a gas was evolved and it is sulfur dioxide. We can check that by using a moisture filter paper because sulfur dioxide will reduce dichromate ion to chromium 3 plus ion. Chromium 3 plus ion is green in color, so the moistened filter paper with potassium dichromate turns green. Procedure. You have given a sulfide solution. Add few drops of silver nitrate solution to the sulfide solution. A black color precipitate observes. In the next part of the experiment, you have given a powder of sulfide ions. Add diluted hydrochloric acid to the given powder. After some time, use a filter paper soaked with lead acetate solution and place it over the top of the test tube. The color of the filter paper will become black. Observations and results. For the given sulfide ion solution, when we add silver nitrate, silver sulfide is produced. Its color is black. In the next part of the experiment, when we add diluted hydrochloric acid to the given powder, hydrogen sulfide is emitted. Hydrogen sulfide will react with lead acetate and form lead sulfide. So, the color of the filter paper soaked with lead acetate solution will turn black. Procedure. You have given a thiosulfate solution. Add few drops of diluted hydrochloric acid solution. A gas evolves and after some time a yellow-white precipitate observes. A filter paper which is moistened with acidified dichromate is placed on the top of the test tube. Now you can see the color will change into green. Observations and results. When we add diluted hydrochloric acid solution for the given thiosulfate ions, a gas evolves and after some time a yellow-white precipitate observes. The gas evolves is sulfur dioxide and the yellow-white precipitate observes is sulfur. We can check sulfur dioxide by using a filter paper moistened with potassium dichromate. Sulfur dioxide can reduce dichromate ion into chromium 3 plus ions. So, the color of the filter paper will turn green. This experiment can be done to identify sulfide ions. But in the thiosulfate ion solution, a yellow-white precipitate observes. But in sulfide ion solutions, we cannot observe a yellow-white precipitate. Procedure. You have given a solution of thiosulfate. Add silver nitrate solution and warm the solution. Initially, a white precipitate forms and turns into black after some time. For the next part of the experiment, you have given a thiosulfate ion solution. Add few drops of lead acetate solution to the given solution. A white color precipitate forms. Heat the resulting solution for several minutes. When heating, the precipitate color will change to black. Observations and results. For the first part of the experiment, when we add silver nitrate ion solution, silver thiosulfate produces. Silver thiosulfate is a white color precipitate. When we heat, silver thiosulfate will convert to silver sulfide, which is a black color precipitate. For the next part of the experiment, when we add lead acetate solution, lead thiosulfate is produced. Lead thiosulfate is white in color. When we heat it, it will convert to lead sulfide. Lead sulfide is black in color. Procedure. You have provided a nitrite ion solution. Add few drops of diluted hydrochloric acid to the given solution. A brown color gas evolves. You have given a nitrate ion solution. Add few drops of freshly prepared saturated ferrous sulfate solution to it and add concentrated sulfuric acid slowly down the side of the test tube. A brown color ring observes. Observations and results. When we add diluted hydrochloric acid for the given nitrite ion solution, a brown color gas evolves, which is nitrogen dioxide. For the given nitrate ion solution, first add freshly prepared saturated ferrous sulfate solution, and after that, when we add concentrated sulfuric acid slowly down the side of the test tube, we can see a brown color ring observes. This is because due to the formation of this given complex. Procedure. You have given a nitrate or a nitrite ion solution. Add small amount of aluminium powder to the given solution. Then add concentrated sodium hydroxide for the given mixture. Place a litmus paper on the top of the test tube. The color of the litmus paper will turn to blue. In the first experiment, we can observe a gas with sharp suffocating odor, which is ammonia. Ammonia is a basic gas, so it can change the color of the red litmus paper into blue, or filter paper soaked in Nestor reagent can be turned to brown by using ammonia. Procedure: you have given a carbonate iron powder. Add diluted hydrochloric acid to it. Pass the liberate gas immediately into the lime water using the delivery tube. First, the lime water color will turn into milky. But when we continue passing the excess gas into lime water, the solution will turn colorless again. Observations and results. When we add diluted hydrochloric acid for the given carbonate iron powder, we can see a gas evolves, which is carbon dioxide. Carbon dioxide can turn the color of the lime water into milky. But when we continue passing the excess gas into lime water, solution will turn colorless again. This is because calcium carbonate will react with water and carbon dioxide to form calcium bicarbonate.